You can freely download this practical notebook from my website. From its home page, go to middle left and click Books and Notes. A new web page will open. Then download third book in PDF format.
Perform the experiment, and the name of the experiment is to find the refractive index of liquid using concave mirror. The operators used to perform this experiment, we need stand, mirror and a needle. Then we will adjust our operators according to this diagram. We will find out the approximate focal length concave mirror by focusing some image or light. Step 1. We are measuring the approximate focal length of the concave mirror like this one. We are focusing some image or the source of light which is coming or falling on this mirror, and we are seeing or focusing the image on this wall on a screen, for example like this one. So mathematically, the distance of this focusing image on the screen to the mirror, that is known as the approximate focal length of this concave mirror. We want to measure the height of this needle from this mirror without liquid in order to find the refractive index of the liquid. Because mathematically, if you want to find out the refractive index of the liquid, it is the ratio of the height of the needle from the surface of the mirror without water and with water. So in our second step, we are measuring the height of this needle from the surface of this mirror without water, and for this purpose we will adjust the height to remove the parallels of the needle and the image like this one. The inverted image of the needle can be seen through this mirror, and by adjustment the height like this one, by moving it up and down, the tip of the image and the object, mean image through mirror and the object is this one. They must be at the same position when we are moving our head right or left. The image and the needle should move with one angle. So this is a way by which you can remove the parallels. And when you will done it, then we will have a plumb line, or using the meter rod like this one, by placing the tip of the meter rod at the center of the mirror and the tip of the mirror on the scale. This vertical distance is equal to the height of this needle from the surface of the mirror without. Third point, because our objective is we want to measure the refractive index of the liquid with the help of the concave mirror. So now we are using liquid here, water, so we'll pour some water. We'll pour some water to make a thin layer of water on this mirror, and then we'll again see the image of the needle through the water. So we are pouring a small amount of water on this concave mirror. Now again, we are observing the image of this needle but through the water. When there is a thin layer of water between object and the image, between the surface of the mirror, you will again see the parallax. So now we are going to again remove this parallax by adjustment of the height of this needle. So again, the parallax have been removed, and similarly we will measure the height of this needle from the surface of this mirror when water is present. So this height is equal. Concave mirror, tripod stand, needle, plumb line or meter rod for the measurement of the vertical height. By adjustment of the height of the needle vertically, like this one, when the parallax will removed, you can see through a mirror that the image of the needle will be coincided with the needle tip. And by moving your head left and right, the tip of the image and the needle, they should move with one another without any break, like this one. For example, this should not happen. If this is happening, it means there is a parallax and this is a source of error. It is a exact position, like this one. This is the way by which you can remove the parallax without water on the surface of this mirror. By pouring, we will pour some water on the surface of this mirror, and again we will remove this parallax. Similarly, again we will remove this parallax by adjustment of the height of the mirror from the surface of the water. Observations and calculation. Step 1, we will measure the approximate focal length of the concave mirror. That let us suppose maybe 10 cm, maybe 8 cm or something else. Then we will take 3 observations. Height, then we measure the height of the needle from the surface of the mirror after removing parallax with the help of the meter rod or with the help of the plumb line. So this column represents the height of the needle from the surface of the water, from the surface of the mirror after removing the parallax, and this column represents the height of the needle from the surface of the mirror after removing the parallax. This is say H1, this one is H2. After measuring these heights at the end, we will apply this formula, and the formula is to calculate the refractive index of liquid. Let me suppose here we are using water. It is equal to H1 and H2. So let me suppose for our first observation, the height of the needle from the surface of the mirror after removing the parallax, say that is H1, it is 25.4 cm. And let me suppose that the height of the needle from the surface of the mirror after removing parallax with liquid was water, that is H2, its value is 19.1 of centimeter. At the end, after taking 2-3 observations, we will take the mean value of H1 and H2. You will apply this formula, refractive index of liquid, that is equal to H1 over H2, and our answer is 1.329. And the approximate value of the refractive index of water from table, it is 1.33. Precautions in this experiment of 1 point is the focal length of the concave mirror should be large. The face of this mirror, it must be clean with some chemical like acetone or something else. Third point, you can say that to avoid distortion and high curvature, enough liquid should be used, and when you are taking with the help of the meter rod, it must be noted that the edges should be neat and clean. If they are not neat and clean, so you can take from reading from 1 or 2 as a reference in order to avoid the error in your measurements.
You can take this book from the store or free downloading from my website. These readings are given as a reference. Your reading may be different from these readings.